And we said that if we were solving this guy, we decided that the solution to that system was 1210. That's the point where those two lines intersect and all that stuff, right? And before we did augmented matrices and RREF and all that, do you remember we wrote a matrix equation? We had a coefficient matrix, didn't we? Okay, so what would the coefficient matrix be? I'll give you a hint, it starts with a square bracket. 2. It was that 2 by 2 matrix, right? That was the coefficient matrix. 2 by 2. And then, yeah, we had a column matrix that was the... Yeah, go ahead, John. And that was our variable matrix, right? 2 by 1. By the way, now that we know something about multiplying matrices, when I take a 2 by 2 matrix times a 2 by 1 matrix, what kind of matrix do I get? And the 2 by 1 matrix that we got was 56. That was the constant matrix. Okay. Hold that thought. And let's come back here. I am curious. Is there anyone in the room that knows how to solve this equation? All right. So there's the challenge. Show of hands. Who wants to volunteer to solve that equation? You feel trapped, don't you? It can't be that easy. Come on. You know the answer. $20,000 for volunteer. Okay. Was that you, Alyssa? Martha, you say 4. Congratulations. If I had $20,000, I would give you $20,000. Now, Martha says the answer is 4. Is there anyone that agrees with that? Good. We have some people in here, right? So there's some agreement. Now, Martha, how did you get that 4? That's the interesting question. I'm sorry, I forgot to say there's no such thing as division. Oh, but if I have multiplication, I can multiply by 1/3, and 1/3 exists. So what happens if I multiply both sides by 1/3? Why? Because 1/3 of 12 is 4. Yes, I agree with that 100%. But what's this? These are multiplicative inverses, are they not? And when I multiply multiplicative inverses together, what do I get? I get 1. And if 1 times x equals 4, 1 times anything is that number because 1 is the multiplicative identity, correct? Let's go back here now. Would you let me rewrite this matrix here as matrix A? This is the coefficient matrix. Is that cool with everybody if I just call that matrix A? And is everyone equal? If I call this matrix here my variable matrix, matrix capital X? Does that work? And if matrix A times matrix X equals, let's call this guy capital B. This matrix equation works for me because the only matrix up here that has any unknowns in it is my capital matrix X, right? Everything in matrix B is a known value, everything in matrix A is a known value, so these are known quantities here and here. But my unknown quantity is X, right? So suppose I wanted to solve this thing for X. Isn't this the same thing as this? So how do I solve for that X? Remember, there's no such thing as division, right? There's no such thing as 1 over A. Now, matrix multiplication, the order matters. It's not commutative, right? So if I multiply by A inverse on the left over here, I have to multiply by A inverse on the left over here. And what is A inverse times A? By definition. Well, yeah, this is going to be I times X equals A inverse times B. But then Alyssa, what's I times X by definition? Like this?
No.
That seems more distracting than anything. Like that? Okay, so for Samantha's sake, we had A times X equals B, and if we multiply the left side of both these by A inverse, then multiplying by A inverse on the left is going to give me the identity matrix I equals, I times X equals A inverse times B. And since I is the identity matrix, I times X is still X, and X is going to equal A inverse times B. So what we could do, for reasons that you won't fully appreciate, is if I wanted to okay, I'm quitting that. I'm going to go back and I'm going to make matrix A that 2 by 2 coefficient matrix. 2 by 2. I'll make it 2, -9, 3, and 2. Okay? That's my matrix A. And if I wanted to, I'm going to do, I'm going to change matrix B to that 2 by 1. That was negative 66. And positive 56. Okay? So A and B are those two matrices. Okay? So an alternative way to doing an augmented matrix and RREFing is I could instead write this as two matrices, and the solution to that system of equations could be found by using the inverse of the coefficient matrix times the constant matrix. And it's the 12th in there.